Welcome to Inside Insights, your quick hit of tips, tools, and trends for manufacturing, distribution, and Dynamics 365 Business Central, brought to you by InsightWorks.
Imagine you're sitting on your couch, streaming a movie, and suddenly the Wi-Fi drops.
Yeah.
It's a mild annoyance, right?
Oh, yeah. Super frustrating. You just stare at the buffering wheel.
Exactly. But now, I want you to scale that frustration up. Picture a multi-million-dollar supply chain operation.
Oh, wow. Yeah, totally different stakes.
Right.
Yeah.
The forklifts are humming, the trucks are idling at the dock, thousands of units are flying off the shelves.
Yeah.
And then, a totally invisible wall made of radio waves brings the entire operation to a grinding halt.
It's catastrophic. We really do treat the internet like this invisible utility.
Like oxygen.
Yeah, like oxygen. We just assume it will always be there. But industrial environments are, they're uniquely hostile to wireless networks. And losing that connection produces these immediate cascading financial effects.
Welcome to today's deep dive. We've got a stack of sources today detailing a system called Warehouse Insight, which is built specifically for Microsoft Dynamics 365 Business Central.
It's a really fascinating system.
It is. And our mission today is to understand how you keep a massive, complex logistical operation running when those invisible tethers of the network inevitably snap.
Because they will snap. It's not a matter of if, but when.
Exactly. So the core premise of Warehouse Insight is putting barcode scanning and mobile workflows directly inside Business Central. The ultimate goal here is kind of the holy grail of logistics, keeping the physical warehouse and the digital data perfectly synced in real time.
Right.
But, and this is a huge but, a physical warehouse is practically designed to destroy a Wi-Fi signal. I mean, you are dealing with towering racks of solid steel.
Which acts like giant Faraday cages, yeah.
Exactly. Faraday cages, thick concrete walls, distant loading docks. Plus, you have these peak periods where hundreds of devices suddenly wake up and overwhelm the access points all at once.
What's fascinating here is the profound tension between a perfect digital ecosystem and an incredibly abrasive physical environment.
Yeah, that's a great way to put it.
Because, real-time data sync allows for razor-thin margins. It allows for incredible efficiency. But it completely relies on that invisible, fragile tether. The moment that radio frequency breaks down, the entire illusion of real-time visibility just shatters.
So we need to establish why that digital and physical sync is so crucial in the first place, just to really grasp the stakes of a dropped connection before we look at how the software actually compensates for it.
Right, the baseline workflow.
Yeah. According to the source material, warehouse workers rely on these handheld devices for practically everything. We're talking receiving goods, put away, picking items for orders, counting inventory, shipping all of it.
And they are doing all of this without ever leaving the Business Central platform.
Exactly. They are highly mobile, constantly moving through different zones of the facility.
And performing those actions directly within the platform provides instant feedback, which is key. The system is architected to catch errors at the absolute point of scan.
So if they mess up, they know right away.
Right. If a worker, say, scans the wrong SQ or the wrong bin location, the device alerts them immediately. They fix the discrepancy in seconds, literally before the physical item moves an inch.
Which brings us to the nightmare scenario from the text. And this really highlights exactly why connectivity drops are so punishing. Imagine discovering that error 20 minutes later.
Oh, that's just the worst.
It sounds awful. Picture a worker doing this massive picking run, right? They're moving rapidly through the aisles, building up a pallet. Then they hit a dead zone. The connection drops.
But they don't necessarily stop.
Right. The system fails to reach the server to validate a scan, but maybe they keep going. 20 minutes later, the network reconnects, and the system finally throws an error for a scan that happened like miles of walking ago.
Which means the worker now has to physically backtrack through this massive facility to locate the origin of the mistake.
It's the equivalent of using a GPS navigation app on your phone and driving into a long underground tunnel.
Oh, that's a perfect analogy.
Right. You lose the signal, but you are obviously still driving. If you miss your exit while you're inside that tunnel, you need the app to alert you right then and there.
Exactly. You don't want to pop out the other side, drive for another 20 minutes, finally get your cell service back, and then have the app suddenly demand you make a U-turn miles down the highway.
Exactly. You need to know in the moment.
And that GPS in the tunnel illustrates the exact vulnerability of a warehouse worker flying blind. I mean, they are executing physical actions in the real world, altering the state of the inventory.
Yeah.
But the central system, the digital map, has completely lost track of their coordinates and their actions. It creates a disastrous drag on throughput.
Because they're doing all this work that might be wrong.
Right. And the cost isn't just the physical time lost walking back through the aisles. You have to factor in the cognitive load and the physical undoing of the work.
Oh, man. Digging through a wrapped pallet to find one box?
Exactly. They have to stop their current task, figure out where the discrepancy began, locate that specific box deep inside a built pallet, fix the physical location of the goods, update the digital record, and then, after all that, try to regain their initial momentum.
In an environment where margins are calculated in seconds, that backtrack is a massive unforced error. So, since we obviously can't magically guarantee perfect Wi-Fi in every corner of a warehouse, the conversation naturally shifts to the failsafe.
How do we stop them from just freezing in place?
Right. Because the default behavior for a lot of legacy systems is just to lock the screen. If the handheld can't reach the server, it throws up a little loading icon, and the worker's paralyzed.
They literally cannot pull the trigger on their scanner again until the server sends an OK response back.
Which is crazy when you think about it.
It is. And high-volume scanning environments often trigger these micro outages. It isn't always a geographical dead spot behind a concrete pillar.
Oh, really? Like just too much traffic?
Yeah. Exactly. If a facility has a compressed receiving window where, say, multiple trucks are offloading simultaneously, or they are doing a facility-wide inventory count, the sheer volume of data packets hitting the access points can cause the network to hesitate.
It just gets clogged.
Right. The access point becomes a bottleneck, and the worker's physical momentum just dies while they stare at a screen waiting for a confirmation beep.
Here's where it gets really interesting. The solution in Warehouse Insight is a feature explicitly called Store and Forward.
It's such a game changer.
It seems like it. When it's enabled, a network hesitation doesn't freeze the screen on the handheld. Instead, the scan data is queued locally on the device's own internal memory.
So the worker receives a localized confirmation from the device itself?
Exactly, which lets them instantly trigger the next scan. And then when they step back into a strong coverage area or the packet congestion clears up, all that locally stored data is just automatically forwarded to Business Central in the background.
The data just simply catches up.
It functions exactly like texting in airplane mode. You write the text, hit send, and you don't just sit there staring at the screen waiting for a delivery receipt.
Right. You put your phone away.
You go about your business. Your phone handles the logistics of actually delivering the message the literal second the wheels touch down, and you get cell service back.
And that decoupling of the physical human workflow from the digital network's latency completely changes the operational dynamic. The warehouse doesn't start just because the network does.
It protects the worker from the friction of the disconnect.
Exactly. It transforms a technological limitation into a seamless human workflow. The technology adapts to the environment to keep the human moving, which is critical because maintaining human momentum is arguably the most expensive and vital resource on a warehouse floor.
Okay, so Store and Forward handles the sudden signal drop, those total dropouts.
But what about the overall quality of the network? Every warehouse has different infrastructure.
Well, absolutely. The hardware reality is all over the map. So our deep dive moves from this broad failsafe into highly specific, customizable tools for IT administrators. Because not every environment behaves the same.
Right. Network bandwidth and hardware capabilities vary wildly from one distribution center to another. One facility might operate on state-of-the-art fiber optics with the latest Wi-Fi 6 access points.
Must be nice.
Yeah, but then their secondary overflow facility might rely on infrastructure from a decade ago, and device age is another massive variable.
Some of those scanners look like they're from the 90s.
Honestly, some of them basically are. I mean, some handheld scanners are essentially modern smartphones with powerful multi-core processors, but others are older, legacy devices running aging operating systems with very limited RAM. Software has to account for all of these physical realities.
Which brings us to a specific feature the sources highlight. Administrators can actually toggle data compression on or off for the communication between the device and the server. They explicitly point this out to avoid a one-size-fits-all default.
Because data compression reduces the payload size of the information being transmitted. It packages the data into a smaller digital footprint.
Which means it sends faster over a bad connection.
Exactly. The server decompresses it upon receipt. A smaller payload requires less bandwidth, meaning it transmits faster over a weak or congested Wi-Fi connection.
Okay, let's unpack this. If data compression makes things run faster over bad Wi-Fi,
Hmm.
and we already know warehouse Wi-Fi is notoriously problematic, why wouldn't an admin just leave it turned on all the time? Is there a catch?
If we connect this to the bigger picture, you have to look at the underlying hardware mechanics. Compressing data isn't free. It requires active processing power.
Ah, I see.
The CPU inside the handheld scanner has to expend computational cycles to execute those compression algorithms before it can transmit anything.
So if you have an older scanner,
Exactly. If a warehouse is utilizing older legacy handheld devices with weak processors, forcing those devices to constantly compress and decompress data payloads will just max out the CPU.
so you're basically trading network lag for processor lag.
Precisely. The entire scanner becomes sluggish and unresponsive in the worker's hand because the processor is pinned at 100% trying to manage the compression overhead.
Wow.
So giving administrators the ability to toggle this feature provides them the practical power to tune the performance specifically to their unique hardware bottlenecks.
That makes total sense.
Yeah.
So if a facility has great Wi-Fi but really old scanners, they just disable compression.
Right. And if they have terrible Wi-Fi but brand new, highly capable scanners, they enable it. It shifts the processing burden to wherever the system has the most excess capacity.
Now, the customization gets even more granular when we talk about specific workflows. The text outlines operations built using a feature called App Designer.
Which is very powerful.
Yeah, it lets a warehouse create totally unique multi-step digital processes tailored to their exact business logic. But for these custom workflows, admins have access to a specific building block called the Wait for Network queue.
Because creating custom multi-step processes introduces severe risks if the network drops mid-execution.
Right. The sources explain that this specific block physically pauses the workflow on the device until all pending network operations complete. It literally prevents the worker from moving to the next step.
Some operations just require absolute data integrity before moving forward.
Yeah, instead of the system timing out or generating inconsistent results because it skipped a validation step, the workflow safely holds its state and waits.
It acts as an absolute gatekeeper for data integrity. The software logic recognizes that for certain high-stakes operations, the store and forward methodology is entirely inappropriate.
Because you don't want to just assume a really critical step went through.
Exactly. You cannot asynchronously queue a data payload if the very next physical action requires the server's validation of that specific payload.
Like what kind of action?
Say, a critical quality assurance hold, or the generation of a compliant shipping label. This block allows an administrator to selectively dictate that for a particular task, data integrity supersedes immediate human momentum. You stop and wait for the mothership to confirm receipt.
So we've covered hardware drops and network limits. But sometimes the bad connection isn't the Wi-Fi at all. It's a roadblock created by the software's own rules.
Which happens more than you'd think.
Right. The conversation in our sources moves to how Warehouse Insight handles internal system conflicts during highly active periods. They focus on a feature called Advanced Inventory Count.
This ventures into the really sophisticated logic required for enterprise warehouse management. Specifically, how a system handles concurrent database interactions.
Right, and to understand this, we need to look at how inventory counts use what they call license plates. In a warehouse, a license plate is a barcode tracking unit that represents a specific group of items, like an entire pallet of mixed goods.
It allows the system to track a massive collection of individual SKUs as one single entity.
So instead of scanning 50 individual boxes to verify a pallet's contents, a worker just scans the single master barcode on the shrink wrap.
And the system inherently knows the identity and quantity of all 50 subordinate items. It simplifies the whole tracking architecture.
But during a massive facility-wide inventory count, all this concurrent scanning creates heavy friction. Typically, in legacy systems, if a worker scans a license plate that the database thinks is already assigned to another active count, like maybe another worker scanned it hours earlier but left their session open, the system immediately throws a red flag.
Right. It actively locks the record and blocks the new scan. The legacy system is just enforcing rigid data protection rules.
It doesn't want two people messing with the same data.
Exactly. It detects that two distinct user sessions are attempting to manipulate the state of the same physical pallet simultaneously. To prevent a database conflict, it just halts the secondary action entirely.
And without the advanced inventory count feature, the sources point out that workers just hit a brick wall on the floor. The software prevents them from continuing their count.
They literally have to stop physical operations, track down a supervisor, figure out who owns the locked record, and resolve the conflict before the software lets them scan the next pallet.
But with Warehouse Insight, license plates assigned to other active counts do not block scanning. The system just accepts the input. The worker scans the locked pallet, the count moves forward seamlessly, and the text states that conflicts are resolved through a normal process later.
Rather than stopping everything on the floor.
So what does this all mean? Let me push back on this a bit. Isn't letting a worker scan a conflicting license plate just creating a massive data mess for someone else to clean up later? Why intentionally push a conflict down the line instead of fixing it right there?
That is the million-dollar question, and it requires a fundamental shift in how we view resource allocation in an industrial setting. You have to evaluate the true cost of your resources.
Okay, go on.
Server space is cheap. The data processing time required to reconcile a conflict is virtually free. But human momentum on the warehouse floor is extraordinarily expensive.
Ah, I see.
Forcing a physical worker to stop their cadence, put down their equipment, walk to a terminal, untangle a locked software record, and then walk back to resume their physical task, that creates an unacceptable financial drain.
So you are actively choosing to absorb a software discrepancy to protect the physical throughput.
Yeah.
You're saying the human's time is worth more than the computer's time.
Exactly. Pushing the conflict down the line is a highly calculated optimization. It is exponentially more efficient to let the physical worker complete their physical task. Just let them finish counting the aisle without interruption.
Even if the data gets a bit messy.
Let the software collect the messy, conflicting state data, because later, a single inventory control manager sitting at a desk utilizing a full keyboard, a large monitor, and dedicated dashboard tools can review those digital discrepancies and resolve them in seconds.
Wow, that really puts it in perspective. Resolving a conflict digitally at a desk is vastly cheaper than resolving it physically on the floor.
It completely inverts the standard enterprise software dynamic. The software is actually engineered to serve the messy, overlapping physical reality of the warehouse rather than forcing the physical workers to halt their jobs just to satisfy the software's rigid database rules.
It's acknowledging that a warehouse is a highly dynamic, inherently chaotic environment.
Yes. If your software architecture demands absolute sequential perfection at every single node, the system will constantly fracture under the weight of normal operations.
It just breaks.
Exactly. By engineering deliberate elasticity into the system, whether that means caching payloads locally during a Wi-Fi drop, or tuning the compression algorithms to match the CPU capabilities, or even allowing conflicting inventory scans to proceed, the software achieves true operational resilience.
So to sum this all up for you listening, connectivity challenges are just an unavoidable reality in warehouse environments. Whether they stem from towering concrete walls, access points choked by high-volume scanning, or rigid internal software locks. You can't just install your way out of them with more routers.
No amount of routers will fix the basic physics of a steel warehouse.
Right. And the source material makes it incredibly clear that Warehouse Insight is fundamentally designed for business central operations that acknowledge this reality. They need to keep moving, even when conditions are far from perfect.
It is the practice of designing enterprise systems for the physical world as it actually exists, rather than the idealized world network engineers wish it was.
Well said. If your supply chain is actively battling these latency and connectivity bottlenecks, and you want to explore the technical architecture we've unpacked today, the source material recommends visiting wms4dynamics.com. You can also talk to your Business Central partner to learn more about how these specific tools might deploy within your own infrastructure.
And as we step back from the technical mechanics here, there is a broader philosophical reality to consider, something for you to mull over.
Yeah, lay it on us.
We spend so much time in modern business obsessing over the future of logistics. We obsess over the integration of predictive artificial intelligence, fully autonomous robotic picking fleets, drone delivery networks.
Oh, absolutely. Everyone wants the shiny new thing.
Right. We are constantly chasing these high-end digital miracles. But if a simple data station in radio frequency near a steel loading dock can still bring a multi-million-dollar fulfillment operation to its knees, we really have to ask ourselves, are we fundamentally taking our basic physical infrastructure for granted while we chase the bleeding edge?
Are we trying to orchestrate an autonomous supply chain before we've even guaranteed the digital plumbing?
Exactly.
That's a great question. The next time you are in a massive distribution center, look up at the access points mounted 30 feet in the air, surrounded by thousands of tons of steel. Consider the invisible, incredibly fragile web keeping every single barcode scanner, forklift, and shipment perfectly synced.
It really is a minor miracle it works at all.
It truly is. Well, thank you for joining us on this deep dive. We'll catch you on the next one.